Modern batteries have increasingly specific performance requirements, and carbon black has proven to be a key component in meeting them. The next step contains electrode manufacturing and testing. The slurry is coated onto an aluminum or copper foil. A homogeneous slurry ensures an even distribution of carbon black. The coated foil is then dried in an oven. Afterwards, the electrode is compacted using a calendar. This step enhances particle contact and improves conductivity. Next, the electrode is punched out. To evaluate its quality, a precise volumetric resistance test is conducted. This test measures the electrical resistance in ohms. A low resistance indicates that the carbon black and active material are well distributed in the electrode layer, ensuring consistent electron flow through the percolation network. This enhances the current flow and the battery performance. Additionally, it reduces the risk of overheating and improves battery longevity. Once the electrode is ready and coated on one side, a small circular section is punched out, preparing it for the next stage, battery cell assembly. Ultimately, every step, from the carbon black formulation and dispersion to coating, electrode production, and final assembly, plays a vital role in ensuring the performance, safety, and longevity of the finished battery.